All right, so here we go. Example 5 on section 2.6, the chain rule. These questions all kind of look similar to each other, but they're all very subtly different. All right, so we're finding f prime and then simplifying. So f of x equals cosine of 5x squared. What are we taking the cosine of here?
5x squared.
The quantity 5x squared, yeah. By default, if there's no parentheses, you would take the first term after the trig function. So if we saw cosine of 5x squared plus 1, what would we be taking the cosine of? Just the 5x squared. That's how we understand it to be. Therefore, if you intended to be the 5x squared plus 1, you would have to force parentheses around it. So you don't really need the parentheses there. Good. But I'm going to go ahead and add parentheses to help see layers, because now it's cosine of blob, and it's a composite function, which means we use the chain rule. So what does the left side become? Good. F prime of x. The derivative of cosine of blob is negative sine of the same blob. Remember, you don't take the derivative of the blob at this moment. Only one layer at a time. That was the outside layer. And then times the derivative of the inside layer is 10x. Good. So when you simplify that, you can now pull the 10x in front, negative 10x sine of 5x squared, and you wouldn't need the parentheses anymore. So, ta-da! Kind of fun. Fun easy. That was fun easy. All right, letter B. Now what are we taking the cosine of? 5. Notice the parentheses are already there, so you take it as is. So what is cosine of 5? I don't know. Is it positive or negative? Is it a number or a variable? It's a number. It's cosine of 5 radians. 5 radians is in which quadrant? Probably the fourth, right? Because once around is 6.28, so it's in the fourth. So it should be a positive number, right? Cosine of 5 is some positive number. So the variable is x squared. So here we go. F prime of x is multiply and subtract, right? The constant that's there just goes along for the ride. If it were a 3, we could go 2 times 3 and call it 6. But in this case, we'll just call it 2 cosine of 5 times x squared. And if I write it like that, is that good? Right. You would need the 2 cosine of 5 in parentheses again, or the x squared in parentheses, because remember, without it, you would assume it would be cosine of 5x squared. So cosine of 5 was just a number. Oh, I meant just x. Right. I do just mean just x. Whew. Now it's more correct. I forgot to subtract. It's a two-part thing. Multiply and subtract. Don't just multiply. Learn from my mistakes. A, B, C comes next. What are we taking the cosine of? 5x squared. Yeah, what are we squaring? The 5x. Yeah, so that's very important. I see some people kind of carelessly writing stuff, like when they take the derivative of tangent, the derivative of tangent of x, I see some people writing it like this, secant squared of x. Is that secant squared of x? No, that's secant of x squared. So say what you mean and mean what you say. Rachel's challenge. Okay. So secant squared of x is either written like that or like this. One of the two. But not secant of just x squared. Okay. So we should simplify early and often. If I do it right now, it's going to be a chain rule. Okay. So let's go ahead and do that. Cosine of blob. What's the derivative of cosine of blob? Negative sine of the blob. Good. Times the derivative of the blob. What's the derivative of the blob? Well, now I don't even really see the 5x yet. I just see blob squared. Do you see blob squared? So it'd be 2 blob to the first. And then times the derivative of the innermost blob, the derivative of 5x is 5. So if you do it like that, you'll have 3 links in your chain. That's correct, but I don't think that's the way I would recommend you do it. I would recommend you do it like this. Simplify first. What is cosine of 5x quantity squared?
All right, you're good.
Okay, thank you. Oh, the printer. Yeah, 25x squared. Now, you only have 2 layers instead of 3. Less likely to make a careless mistake. So now it's negative sine of 25x squared times the derivative of 25x squared, which is 50x. So you do get an equivalent answer, but one less layer, one less opportunity to make a careless mistake, which I almost wrote 2x squared instead of 25x squared. Okay, so there you go. Any questions on that one? So good so far? So good, so far. All right, now what are we squaring? The s or the cos? Or the whole cosine? The whole cosine. So this is the condensed version, as we just said. This is equivalent to the following. And that helps you when you're doing the chain rule or evaluating, because it's the expanded version. How many layers do we have now? We do have 3. So if you want to add parentheses around the 5x, that's another layer. So blob squared, cosine blob, and then the blob. 3 layers. So 3 links in our chain, 3 factors. Outside in, blob squared comes first. Its derivative is 2 blob to the first. Okay, get that out of the way. 2 blob to the first. You don't even know what's inside the parentheses. Could be cosine of 5x. Could be tangent of x squared. Could be 7. We don't know. Now that we've finished the outer layer, we go inside one layer and we're like, oh, it's cosine of blob. The derivative of cosine of blob is negative sine of the blob. And again, remember, don't put dot negative. Put parentheses or dot parentheses. And then times, now we're inside the innermost vault here in the pyramid, and we're hoping for like an undiscovered fortune, mummy's tomb with fortunes all around. But instead, we get 5x. Times the derivative of 5x is 5. Okay. Now you can clean it all up. There's 2 ways to do this. First of all, if you simplify your coefficients, you got a 2, a negative, and a 5. That's going to give you what for your coefficient? Negative 10 cosine of 5x, sine of 5x. That's one way to do it. Yeah? Or the other way to do it, Garel. Is that what you were saying? What is 2 cosine of blob times sine of blob? That's equal to sine of 2 blob, which would be 10x. Remember, that's your double angle identity. 2 sine of blob cosine of blob is equal to sine of twice the blob. So if I use those underlined pieces, what am I still left with as my coefficient now? A negative 5. So negative 5 sine of 10x is also correct, using the double angle identity. I like that version. Okay, hint, hint, wink, wink. All right, letter E, letter E. You want to use the Hody High rule on this one? No, good. Because there's a constant in the top, this one's going to be faster and therefore more efficient and less likely to make careless mistakes if you bring the whole thing to the top and say it's to the what power? Negative half, good. And then I'll put parentheses around the 5x. So now it's just a chain rule again with 3 layers. So f prime of x working from the outside in. Negative 1/2 blob to the what power? Negative 3/2, yeah. And I don't know if I've mentioned, I think I have though, sometimes when people write it like from left to right and they don't do it like this, if they go, it's negative 1/2 times the blob, and they go ahead and write cosine of 5x, by the time they close the parentheses, sometimes I've seen them forget to put the exponent. So just be very mindful. I like to go negative 1/2 blob to the negative 3/2, and then come back and rewrite the blob. And now times parentheses, the derivative of cosine of blob is negative sine of blob, times the derivative of the blobbiest of all blobs, the innermost blob, you get 5. Yeah. Now, are we going to be able to use the double angle identity for sine on this one to condense it? No, not unless I do some crazy factoring out, because I got a cosine to a fractional power, not to the first power. So this one, I'll just simplify all of your coefficients, negative 1/2, a negative 1, and a 5 to get 5/2, good. And then I'll put the cosine, it's negative. I'll go ahead and throw it in the denominator, put it back under a square root, and call it cosine cubed of 5x. And on the top, I'll have sine of 5x. So there's kind of the nicest way to simplify it. Putting the cubed back in the condensed notation, so you don't need parentheses. There's a cleaned up, nice looking version of that dude. All right, so that's A, B, C, D, E. What comes next? F. All right, cosine of 5. 1. Note to self, on Garel's test, put answer choice A as 1. 1 times 0. Is that what you meant? Yeah, that's 0. Just call it 0. Okay, okay, cool. Yeah, because cosine of 5, where's the variable in cosine of 5? Is it the C or the O or the S? There's not one. We already talked about cosine of 5 today. It's some positive number. Is it closer to 1 or closer to 0? Probably closer to 1. Yeah, probably closer to 1. Yeah. Because, 5 is closer to 2 pi than it is to 3 pi halves. So anyway, it's a constant. That's the point we're trying to make. And how fast do constants change? They don't. Right. Good. All right. So just because it looks like something that should have a variable doesn't mean it does. So be careful identifying constants. All right. Any question on example 5? All righty. 6 comes next. Find the equation of the tangent line to the graph of that at x equals pi. So this is the one where you have to kind of map your own strategy. The end result is an equation of a line. So if you begin with the end in mind and work backwards, you can figure it out. So what do we need for the equation of a line? Point and a slope. You need a point and you need a slope. And all I give you is a function and an x value. So let's find the point first. The point is going to be pi comma f of pi. And if I plug into my y value machine that was given, I get 2 sine of pi. Let me go ahead and write that out. 2 sine of pi plus cosine of 2 pi. Now, that is a number that is exact and not simplified. Bless you. If you want to tote that thing around, be my guest. I'm not going to. I'm going to go ahead and simplify it. What is sine of pi? 0. 0 times 2 is 0. So it's 0 plus cosine of 2 pi. What's cosine of 2 pi? 1. So 0 plus 1 is 1. Oh, much more user-friendly. 1 than all of that. Okay, sweet. So now we have the ordered pair. So now we need the slope at that point. Slope at a point, slope at a point, slope at a point. That is the derivative. So I ultimately need f prime of pi. That's the slope, f prime of pi. But before I can find f prime of pi, unless I'm using the modified form or the alternate form, no thank you, I need to find f prime of what first? X. Okay. So off to the side here, f prime of x. 2 terms, so it's like 2 separate derivatives. 2 sine of x becomes just 2 cosine of x, right? Nothing tricky about that one. And now the derivative of cosine of 2x, that's the chain rule. So I'll put parentheses around the 2x. The derivative of cosine of blob is negative sine of the blob, and then times the chain rule. The derivative of 2x is 2. Now do you see what I did there? If it shows up, there it is. Once you do the chain rule enough times, you realize that, you're always unpacking boxes to the right just because we write from left to right. And then in the end, when you rewrite, you pull your coefficients out front. So if you anticipate that a little bit, put in minus here and leave a space, and then you can unpack the box to the left. The derivative of 2x is 2. And it just saves a line of writing. Not that it's required or anything. So f prime of pi now, if we plug a pi into that, we get 2 cosine of pi minus 2 sine of 2 pi. And let's see, cosine of pi is negative 1. Good. Times 2 is negative 2. And what's sine of 2 pi? 0. So it's negative 2 minus 0, which is just negative 2. So now we've gathered all of our things, all the ingredients we need for our equation of a tangent line. So here we go. The equation, it's going to be in Taylor form. Y equals the y value of 1 plus the slope, which turns into minus 2 times x minus pi. That's the tangent line. And what the heck, since we're right here, what's the equation of the normal line? Good. Y equals 1 plus a half times x minus pi. The only difference in the Taylor form is now you have the opposite reciprocal slope there. Keep bearing in mind, though, that that's not the only difference in the equation of the line if it were in slope-intercept form. It would have a different y-intercept. And you could verify that by distributing and combining like terms. But I'm not going to do that. Okay, cool. Any questions on example 6? We're making good time today. Yes?
So if you were asked to find the solution of the derivative for something, or like whenever the slope is equal to 0, would you want to simplify cosine of 2x into sine so you can solve for 1 before or after?
Oh, good question. if I ask you at what point does our function have horizontal tangent lines, is that what you're asking? Yeah. That's really what we're going to be doing kind of moving forward here. I would want to know, okay, for what values of x is the derivative 0? Because those are your horizontal tangents. Those are your potential local max and local mins. So what you would do then is you would actually take the expression part of your derivative and set it equal to 0. So let's review that. I'm glad you brought it up. Right now, that's going to be a hard equation to solve the way it's written, isn't it? Because the angles are not the same. So this takes us back to pre-cal when we were solving trigonometric expressions or equations. So our first goal is to make the angles the same. Is it easier to build up an angle or to tear down an angle? Tear down an angle. Good. So in this case, you would want to replace sine of 2x with that identity that we've already used today. So you'd have 2 cosine of x minus 2, beefy purple bracket. Sine of 2x is 2 sine x times cosine x. And that equals 0. Now when you simplify, you get 2 cosine x minus 4 sine x cosine x. And this makes it a lot nicer to solve. Because now the angles are the same, and there's two terms. And now you have a common factor of 2 cosine of x. So 2 cosine of x, parentheses, you're left with 1 minus 2 sine of x. So not only did it put the angles in terms of the same, but it also gave you a common factor, which made it two separate problems now. So 2 cosine of x equals 0, or 1 minus 2 sine of x equals 0. This actually works out pretty nice. I might just add this to it. You saw that. That's good. So now it's 11:01, but according to my watch, guess what time it is? Unit circle time. That's what time it is. It's everyone's favorite time, boys and girls. It's unit circle time. Or time circle unit, because we're using it in reverse. Cosine of what angle is 0? Pi halves and 3 pi halves. So we'll stick within one positive rotation. Sweet. And this one's the same as sine of x equaling 1/2, if you go ahead and solve it for sine of x. And now it's unit circle time again. Where is sine equal to positive 1/2? Pi 6 and 5 pi 6. So that function, the original function, f of x, has 4 horizontal tangent lines within 0 to 2 pi. I like that. That's a nice little addition to this problem. That's the power, really, of using the double angle identity here. It just doesn't make it a different form of a right answer on a multiple choice question. It actually makes it so you can solve it algebraically or trigonometrically. All right, so example 6, this was the bonus. All right, example 7. We're almost getting to the end here. Bittersweet. There's more math waiting for us around the corner, though. Suppose that the differentiable functions f and g. Okay, so the first thing you're going to read is that. If f and g are differentiable, they are also what? Yeah, they're also continuous. So now we know we can use the IVT if we need to, right? And later the MVT or the EVT. And so selected values are given in the table. Evaluate the derivatives with respect to the following at the given value of x. All right, so we want to evaluate twice f of 3x halves at x equals 2. So let's go ahead and do this. Let's call those expressions y equals, because it's a little bit easier to do when you have an equation instead of just an expression. All right, so now I'll take the derivative. Y prime, that's the left side. On the right side, the 2 goes along for the ride, and we have a chain rule, don't we? We have f of blob. So working from the outside in, what's the derivative of f of blob? We're just using notation, right? What's the derivative of f? F prime. Good. The derivative of f is f prime of the blob, and then times the chain rule, the derivative of the blob. Well, 3x halves is the same as 3 halves times x. So what's the derivative of 3 halves times x? 3 halves. Sweet. And now if I simplify, it looks like the 2's are going to divide out, and I'm left with 3 f prime of 3 halves x. And now I'm using the Virginia Hokies or the Clemson Tigers colors, which, okay. Now I can plug in. we're plugging in at x equals 2. So this is why we kind of made it an equation. I can now say y prime of 2 is going to equal 3 times f prime of, if you plug in a 2 there, what's 3/2 times 2? 3. And now, where in the world am I supposed to get f prime of 3? From the table chart at the top, yeah. F prime of 3. So hopefully it's there. If it's not there, you did something wrong at this point. But it's there. Lo and behold, 2 pi. And so we're left with 3 times 2 pi, which on a free response we could stop there, right? Well, on a multiple choice we keep going. 7 pi minus what, Gorell? Pi, minus pi. Right, yeah. 6 pi, very good. 6 pi, 6 pi, 6 pi. All right, so that's how all of these types of questions are done. You could take the derivative using notation and then plug in and fill in values from a table. So let's go ahead and just keep going. These are going to get kind of boring. Letter B, y equals, I'm already bored. Y prime is equal to f prime of x plus g prime of x. That was easy. There was no chain rule or anything involved. Boring. Y prime of 3. That's f prime of 3 plus g prime of 3. Well, let's see. That's going to be 2 pi plus 5. And that's about as simplified as we're going to get it, right? 2 pi plus 5. Excellent. Yes?
When we're writing out the derivative equation, can we just write f prime?
Yes. You can just use the name there. So y prime is f prime plus g. But then when you're showing the substitution of the number in, you would need to go back to the parentheses. F prime of 3, g prime of 3. All right. With that in mind, let's go ahead and do that over here. We'll call this y equals. That's f times g. This is like the product rule as I gave it to you, right? Tyler, what's the derivative of f times g? Say it with that wonderful cadence. F prime g plus f g prime, right? Right? F prime g plus f g prime. Remember that? Yeah, 2 factors, 2 terms. Take the derivative of each one separately. And that's the way I do it. Some people like to go f g prime plus f prime g. Hey, knock yourself out. That's great. It's hard to mess up because multiplication and addition are both commutative. The only way to mess up the product rule is to go f prime g prime. That doesn't even make a good song, right? F prime g prime. Not like f prime g plus f g prime. That could be like a whole beat in the background. Okay, now we're plugging in 3. Y prime of 3 is f prime 3g of 3. This is a bad song too. Plus f of 3g prime of 3. And now we pull in those values from the chart table. Should we finish it, or is this is an easy part? It's not fun to do this with iPads. It's not fun with iPads because now you get tunnel vision. All right, you got to zoom out and zoom in, and then your thumb muscle starts hurting from all the pinch zooming. All right, g of 3 is -4, plus f of 3 is 3, g prime of 3. Also, when you're zoomed out, your writing gets horrible, right? Look at that. Look at kindergarten wrote with the left hand. A right-handed kindergartner wrote with the left hand. That's -8 pi plus 15. Okay, sweet. So if y'all are okay the rest of the way, I'm just going to forego the plugging in. Is that okay? Y'all can handle that. We'll just get to the derivative, and then y'all can infer from there. All right, this is like the Hody-High rule. It is the Hody-High rule. So y prime is ho d high minus high d ho, all over ho ho. So that's g squared. Now of 2, y prime of 2 is g of 2, f prime of 2, minus f of 2, g prime of 2, all over g of 2. I'm going to write it like this in the non-condensed version. G of 2 squared. That's a weird looking g. Okay. You could also write it as g squared of 2, but this is a little bit more useful because now you can see your You're squaring the whole quantity. All right, so then plug in from the chart or the table and finish. All right, E. Is that F times G? That's F of G. Is there a pre-cal student somewhere on this campus that still thinks that's F times G? Yes, unfortunately, yes. Okay. The naivete of the youth. All right, so Y prime. All right. How do we take the derivative of this? This is a composite function, right? So it's chain rule. Work from the outside in. F prime G times G prime. F prime G, that's F prime of G, actually, times G prime. And then we plug in a 2. So we get F prime of G of 2 times G prime of 2. And so remember the composition, G of 2 is going to be in the table, and then that output will become the new input for F prime, and that value will also be in the table. We should probably do that one, shouldn't we? Yeah. All right, so F prime of G of 2. G of 2 is 2. Hey, yeah, same. Times G prime of 2. G prime of 2 is negative 3. So now F prime of 2 is a third. So this ends up being a third times negative 3. So the whole thing ends up being negative 1. Yeah. All right, we're making good time here. The next one, the square root of F. How are we going to want to rewrite that one? F of X to the 1/2 power. Yeah, I'll put parentheses around it. There you go. So this is another chain rule. Y prime is 1/2 times F of X to the negative 1/2, and then times the derivative of the inside function F prime, or F prime of X. If you do it on one, you should do it on the other, of X. And now Y prime of 2 is 1/2. I'm going to simplify. That's 1 over 2 square root of F of 2 times F prime of 2. Well, that's the same as doing F prime of 2 in the top. So remember, when you're evaluating, it's probably best to get rid of negative exponents and fractional exponents. And then you can plug in from the table. All right, so far so good? So good so far? Any questions? All right, this one. 1 over G squared of X. OD high? Bring it to the top. So this is going to be G of X all to the what power? Negative 2th power, and I'll say it's equal to Y. So we did two things there. We took it out of the condensed power notation, and we brought it to the top. So now we can see there's two layers. So Y prime is negative 2 times G of X to the negative 3 power times the derivative of G, which is G prime. And now we're evaluating at 3. So Y prime of 3, make sure you show that. That's going to be G prime of 3 times negative 2 all over G of 3 quantity cubed. So I went ahead and plugged in my 3 and brought the negative exponent down to the bottom, which makes it easier to combine your numbers at the end. All right, now the last one, I'm going to give you like a minute or so to do that one on your own, because this one's kind of fun, and I don't want to steal it from y'all. So go ahead. Yeesh. Remember, parentheses are your best friends in this class. Better to have them and not need them than to need them and not have them. But it's ideal when you need them and you do have them. Yeah. When you're doing what? Product? Actually, I did the chain rule. Actually. Yeah, because I did this. When I'm getting the blue, I'm taking the derivative of this. So here's my first term. It's blob squared. Yeah. Yeah, that's why I wanted y'all to do this on your own. It's pretty good stuff. All right, let's go through it. So I rewrote the whole thing, the entire quantity, the big radical to the 1/2 power, and then I went ahead and called it y, of course. But f squared of x I wrote as f of x quantity squared, and g squared of x I wrote as g of x quantity squared. So now, when I walk up to the problem on the very outside, all I see is something to the 1/2, right? So it's going to be 1/2 that exact same something to the negative 1/2. That takes care of the outside layer. Times, you should always get in the habit of going times parenthesis. Times parenthesis. As if what follows is more than one term, you're going to need it. So you have to unpack the boxes as you get to them. I have f of x squared, but when I go inside and I see the first term, really all I see is blob squared. So it's a chain rule. So that first term is going to be 2 blob to the first power. And then times the chain rule, the derivative of f of x is f prime of x. So if you know you don't need the grouping symbols there to the first power, the green stuff, you can get rid of it. It's just 2f times f prime. And then plus, now I move on to the next one, and again I see blob squared. So it's 2 blob to the first times the derivative of the inside, g prime. And then I close that off right there. So as you get to each term, you have to unpack all those boxes before you go to the next term. Now I'm going to plug in a 2, so y prime of 2, and then rewriting it, that blue factor at the very end, he's your numerator. And then, of course, the 1/2 means there's a 2 factor in the bottom. The other eggplant plum factor to the negative 1/2 jumps to the bottom and then goes back onto the radical. So quite a bit of detail there. And then, of course, dot, 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 now you would go to the table of the chart and pull all the values out and plug them in, which I'm not going to be going back and forth, back and forth, back and forth. You actually could do that if you wanted to. But before this 2 divides out like that, it would divide out with that one as well. So that's kind of the lazy way to do it. I've seen people like do it the lazy incorrect way, which is just those 2's and leaving that one. But if you want to do the lazy correct way, I guess that's okay. The better way is to factor out the 2 from both terms in the top and then divide it out. But yeah, the 2's can go away, and that saves maybe a little bit on the plugging in. So anyway, any questions on that one? Kind of tedious, that last one there. But you do have to be detail-oriented to succeed at some of these problems. Okay, then that brings us to the last one here. It says, use the fact that the absolute value of x is the same as the square root of x squared. It's an identity. And the chain rule to determine the derivative of the absolute value of x. All right? So let's go ahead and elevate him to noun status from verb status. Y equals the absolute value of x. We know what that graph looks like, yeah? It has a slope of 1 to the right, and it has a slope of negative 1 to the left of 0, and the derivative at 0 is what? dne. Good. So we could actually sketch the graph of y prime based upon the graph of y. Here's what the derivative would look like. I'll do it on the same graph. I'll just do it with red. So remember, the derivative is the slope. And what's the slope and therefore the derivative everywhere to the right of 0? 1. So I'm going to come up here, put an open circle at 1, and draw a horizontal line. There it is. And then the slope everywhere to the left of 0, and therefore the derivative everywhere to the left of 0 is negative 1. So I'll draw a horizontal line going that way. And then what's the value of the derivative at 0? We've already said it. It's d and e. So on the derivative graph, that's why I have open circles. So that would be y prime to the graph of y. Now, of course, y'all recognize the line by its paw, right? What is the equation for the red graph? Jumpman. Yeah, ¿cómo te llamo? Me llamo Señor Salta. Which is it the absolute value of x over x? Or was it x over the absolute value of x? Mismo. See? Same. Doesn't really matter. Same one. So how can we get the equation absolute value of x over x from the equation absolute value of x? Okay? Well, I'll show you. Let's go ahead and call the absolute value of x, let's go ahead and call it the square root of x squared. Now, I'll write that as x squared to the 1/2 power. And here's where you have to have a high emotional quotient. You have to resist the urge to say, ooh, 2 times 1/2 is 1. That's just y equals x. Because then its derivative would just be 1 and incorrect. So instead, we'll say, okay, I got an x squared on the inside. I got something to the 1/2 on the outside. Here we go, y prime. From the outside in, we have blob to the 1/2. That's 1/2 blob to the negative 1/2. And I just rewrite the blob. Times, as cool as a cat, the derivative of x squared on the outside is 2x. Oh, yeah. And now we'll simplify. The 1/2 in the front and the 2 in the back. And we're left with an x in the numerator. That should be an equal sign. There we go. An x in the numerator, and everything else goes back to the bottom, so we're left with the square root of x squared in the bottom. Oh, and by the way, what is the square root of x squared? The absolute value of x. And there it is. There it is. So that's the denominator version of Señor Salta. So that's how you can work around absolute values. You either do it that way, or you work it as a piecewise function, which would also work. I've already shown you the decomposition into a piecewise function. All right, so that concludes all of the chain rule. Any questions on the chain rule? So the worksheet, someone did not want to do tomorrow. What's happening tonight? Besides finishing the worksheet to 2.6? Is it the bachelor night? Oh, yeah, game 5. The Cubs and the Nats, right? Who do you think's going to get that one? The Nationals. He said the Nationals, so we'll check tomorrow. Or tonight. Yeah, Nationals. Yeah. Strasburg pitched yesterday. Do you think he'll pitch today? No, he won't. Okay. Nothing else going on tonight? Okay. So it's okay to have the worksheet due tomorrow? Monday? I don't care. Worksheet is due Monday. But it depends. That could either like ruin your weekend or make it the best weekend ever. If you spend it with your homework, I think it's the best weekend ever. All right? The worksheet's due Monday. We will quiz tomorrow.